make a co-host to Shyam sir.
Yes, sir. Yes.
Shyam sir, I am audible?
Done.
I think so, Akash sir, you are facing some issue, might be, because Shyam Akash sir. Sir, I think so. There is an audio issue at your end. Deepika, you can also speak. So if Shyam Akash is there, you can listen to the secretary voice sound also.
Yes, sir. Hello. Are you able to hear me?
Sir, if possible, you can do one thing. You can just, I will remove you. You can rejoin the again. Deepika, you can remove the Shyam sir. And again, Shyam sir will join the same.
हाँ तो अभी तो क्या है वरना अपने गोवा में होते हैं या कहीं पे गोवा के भी कॉन्फ्रेंस होंगे तो अपने मिलते हैं वहाँ पे या कहीं ना कहीं तो मिलते हैं ऐसा है हाँ दिसंबर में जयपुर में प्लान करेंगे
Sir, it's not happening. Sir, Aman sir.
Shyam sir, you can just leave the meeting and again request it, so I will admit it.
Yeah, is gone.
Okay.
Deepika, write a simple one message to the waiting board that we will enroll all within 5 minutes.
हाँ दो लोग हैं मतलब दो तीन लोग तो एक्चुअली क्या ये लास्ट प्रेजेंटेशन है ना तो जैसे जैसे वो टाइम नजदीक आता है ना एंडिंग का लोग कम हो जाते हैं ऑन द सिलेक्टेड
Yes.
सेशन में 25-26 लोग थे फिर 17-8 राउंड है एंड अभी people are
सर आप हो ही नहीं यहाँ पे वरना हम तो खिलाते हैं आपको मैगी
कॉलेज वगैरह स्टार्ट हो गया अभी
Yes, Akash sir.
सभी चल रहा है
Am I audible?
अच्छा
Hello.
Deepika, yes, sir, you are audible. Perfect.
Thank you, Aman. Thank you.
Sure, sir, sure. Now I am unmuting you. You are also co-host, so you are able to unmute yourself. So
No,
just
not necessary. I'm not doing anything from my side. Can you communicate to the researcher? Please start your presentation.
Yes, मैं अभी सबको एडमिट करता हूँ सर. जब भी एंड हो तब आप अपने आप को म्यूट अनम्यूट करके आप कमेंट्स दे देना.
Okay. So my end is everything is okay?
Yes, sir. Done.
Okay.
उसमें भेजो WhatsApp पे.
अच्छा, धीरे बोलना. Yes, good morning, good afternoon, and good evening, participants. Welcome to the technical session 6B of the 4th International Conference on WS4. Due to COVID-19, we all are going through a new normal phase, and the team of WS4 wishes you a safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at different levels. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience in research activities. To continue further, this conference has received tremendous number of submissions which has crossed more than 700 plus numbers, 20 plus countries marked through direct submissions and special sessions, out of which 142 papers were accepted by the Technical Review Committee. Once again, we all would like to congratulate you for your research work and to be a part of the success story in the 4th version of this conference. Further, I would like to welcome our session chair, Dr. Shyam Akashe.
Welcome, ma'am.
Welcome, sir. Dr. Shyam Akashe, Dean from R&D Department, ITM University, India. He has more than 10 years of teaching experience. He has authored and co-authored more than 150 research papers in peer-reviewed international and national journals and conferences. So I welcome you, sir.
Thank you.
So we'll begin with our first presentation, that is by Imad. Imad, I've unmuted you. Are you able to hear me?
Yes, hi. I can.
Yes. You can start sharing your presentation screen and begin the presentation.
Okay. So I hope you can see my screen.
Not
Presently,
yet.
Presently it is not available.
Not yet. Not yet. You can try again. Yes.
So
Now it is
Yes.
visible. Now it is visible.
You can start, sir.
Okay.
Ma'am, what is the time? Sorry to interrupt you.
Yeah,
How
you
much
have
duration?
the participants have 10 minutes to complete their presentation and 3 to.
Sir, each presenter will get the 12 minutes for the presentations and 3 minutes for QA. So
Okay.
kindly take care of the time limit also to all presenters.
Good.
Yeah,
Good. Thank you.
Imad, go ahead with the presentation.
So I hope I will get it in time. Okay, thank you for participation. Good afternoon, ladies and gentlemen. Let me briefly introduce myself. My name is Imad Hamadaka. I am a PhD student at the Technical University Braunschweig in Germany, and my supervisor. Can you hear me? Or?
Sorry for the interruption. Yeah, you can continue.
Yeah, please continue.
Okay. I am going today to present to you my current research about clone resistance authentication for medical operating environment. So the purpose of this presentation is to give you an overview of security on the internet medical things and the current security gap in this area. First, I will talk about the IoT scenarios and security vulnerabilities. Then I will show you security requirements, which we collected during this work. Then I will talk about hardware security in the form of physical unclonable function and secret unknown cipher. After that, I will present you the proposed system design with 2 generic protocols, and finally, I will have a conclusion. So since introducing the Internet of Things, IoT, healthcare industry starts developing a new generation of medical devices where IoT covers various domains. Meanwhile, IoT focus just on the healthcare domain. Medical devices, as you know, are instruments and appliances used for diagnosis, monitoring, and treatment of diseases. And in this slide show you some application of IoT applications and how connected medical devices are transferring medical data from the device into the cloud. And we have also here remote access possibility from outside the hospital network. The cloud is a really interesting thing. It's being considered as a new useful infrastructure extension in the IoT and e-health area. There are many reasons for that, but due time restriction, I will talk about just 2 reasons. First, the cloud provides out-of-the-box scalable solution, including load balancing, routing, and additional needed services. Second, the cloud provides cheap online storage, which can use in all e-health and IoT applications. As you can see in the slide, all devices are connected to the network by wired and wireless link. For example, MRI device or MRI images can be collected from the device and can stored also into the cloud. The main idea behind IoT, all patient data should be reachable from everywhere and at every time. As example, the doctor can always receive the collected and transmitted patient data by IoT devices for diagnostic purposes. The question now is how secure are the current IoT environment? Unfortunately, most IoT devices are vulnerable to various kinds of attack. Based on our finding, security researchers have determined vulnerabilities in network protocols used in popular hospital anesthesia and respiratory machines, Currently, successful attacks on commercial glucose monitoring and insulin delivery system are also demonstrated. And as you can see also in our slide, there are also attacks against communication ways between devices and the cloud. So, so much for the overview. Next, I will show you the collected IoT security requirements, which we started. First, we started to identify the security requirements for IoT environments. The proposed security scheme, which we invented, should meet the following security and privacy requirements. First, mutual authentication. Each IoT device should be identified and authenticated before establishing any connection to the server or to any IoT device. Second, access to the patient data is restricted and only authorized user like doctor or hospital staff can get patient information. Third, the system must grant the data integrity. That means all medical devices can verify that an authorized user has not changed or altered the message during the message transmission. And fourth, all system entities such as doctor or nurse and also the medical devices must have access to the patient data and to the system every time and everywhere. And last, the privacy. The privacy of the patient and all system actors must be protected. An adversary should not be able to extract any information from the transmitted message about IoT entities or system actors. Well, that's about the security requirements which we collected. And now let me start with the main part of the work. In the next session, I will talk about physical security. So the physical unclonable function, PUF, were introduced 2 decades ago for fabricating electronic unclonable units for secured identification or for intellectual property protection. PUF is a function embodied in physical Unix structure where its output look like random function. It's easy to evaluate, but hard to predict, even for an attacker with physical access. PUF are increasingly used to cryptographic scheme, especially for device identification and authentication, secure memoryless key storage, IP protection, and anti-counterfeiting as unclonable entities. The idea of using the physical Unix structure to identify units is similar to fingerprint identification of human beings. They were used random pattern on paper optical entities to extract unique entities. Recently, many electronic technologies for PUF initiation have been proposed. We will see in the next slide classification diagram for the most known initiation. We have the electronic PUF, non-electronic PUF, delay-based PUF, memory PUF. But due to the nature of all proposed PUF technologies, virtually all techniques proposed so far had limited use in real-world application due to economic cost factor and failing long-term stability. I will have an example here for SRAM PUF on the next slide. As you can see here, SRAM PUF is one of the most practically used PUF. Intrinsic ID created the SRAM PUF based on the behavior of standard SRAM memory digital chip. And the SRAM works as follow. When the SRAM cell is powered without applying data signal, the state the cell enters depends on their hold voltage differences of its transistors. In practice, this means that some SRAM cells preferably enter the 0 state, others a 1 state, and some show no real preference and enter any of the 2 states with about the same probability. These 3 types of SRAM cells are randomly distributed over the array of memory cells that form the SRAM block. Those cells that always enter the same state can be used to create the unique and device-specific fingerprint. This is the idea behind the SRAM PUF. But security analysis of most popular intrinsic electronic PUFs has been done, resulting that the SRAM PUF unfortunately have a bit error rate of about 6% to 8%. And the majority of such path technique offer idealized DNA-like identity for physical entity. However, all such technology suffer from being highly inconsistent due to being sensitive to aging, temperature, power fluctuations, and other operational conditions. The objective of this slide, or to introduce the path in this slide, is to show the different non-traditional uncontrollability technology and their drawbacks for IoT environment, and why we are recommended to use SUC instead of using PAF. On the next slide, I will introduce the secret unknown cipher. The secret unknown cipher was invented 10 years ago by Professor Adi and is not well known in the public literature. The concept is repeatedly described in this slide. SUC is a randomly, internally self-generated, unknown, and unpredictable cipher. It's inside the device chip where users, manufacturers, or operators have no access or influence on its creation process. Each generated SUC can be defined as invertible, however unknown pseudo-random function. And its works as follows. As you can see here, if we trigger the function with a value from the defined input space, the output of the function taken from same space after function execution. This step can be used as example for encryption. The same can be used also for decryption, but by the decryption step, we use the inverse function. We use not the same function, we use the inverse function of the SUC to get some values which was encrypted by the SUC decrypted. And in our work, we assume that the SUC is based on block cipher design for optimum cost and performance, and involution, that means self-inverting SUC design was also used. So in the next slide, I will show you the key idea of SUC and how the creation process was made. The key idea of creating the clone-resist entity based on the SUC hardware function. That's the key idea. And in the slide, we see the SUC creation process in 3 steps. First, smart cipher designer called Genie, this one, will be uploaded into the non-volatile system on chip, FPGA device. The Genie is triggered in the second step, a cipher designer. The cipher designer starts to design the cipher with the help of the true random generator. And in the third step, the Genie will be kicked out and removed completely from the system of chip device. Now the SUC is created and the enrollment process can start. This is what happens here exactly. The trusted authority enrolls the device by randomly selecting Z of X value of clear text and simulate the device SUC to generate the corresponding cipher text. That means some randomly values will be chosen by trusted authority. It triggers the SUC and the SUC will respond with the cipher text of the input. And this is the key idea of the clone resistance identity. In the next step, I will show you the proposed system, how to get such open systems secured by SUC. The proposed system has 3 main security actors. First, that trusted authority, which is located here in the hospital lab. And second, the remote access server or hospital gateway server, which have direct connection to the trusted authority server. And third, all medical devices which are connected to the hospital gateway server. All communication in or out to the system will be protected by a firewall, as we can see here. And every IoT device should also embed its unique SUC. That's the idea behind. Each device should have own hardware clone resistance identity. There are 2 stages in the authentication scheme, the registration phase and the authentication phase. when new device introduced into the network.
Dear presenter, you just have 2 minutes left.
Okay, I will try to go quickly. The data flow here, as you can see, the data flow first the client transmit data to the hospital gateway server, and the hospital gateway server is the mediator who will store the data into the cloud. If any other device requests the patient data, the client need to build a trusted chain to the cloud and to the gateway server to be able to get the data. On the next slide, I have a simple unclonable operation dynamic chain built between 4 devices. Remote doctor order the nurse to have some modification on a respiratory device, and first the hospital gateway server with the embedded SUC. The target of such unclonable chain of devices provides the device with secure communication and allows the doctor A to order nurse to use the respiratory device in predetermined sequence, such as adjusting the respiratory device parameter after checking the pulse, electrodiagram, and blood pressure to the adaptive controller at C. So next we will see 2 generic protocol and how they work. So I will not go deeper into the steps, but this protocol is a very easy protocol. It's just a key to distribution protocol to build a VPN between all devices. That means if device A want to communicate with device M over device C, they will have the same shared key. And the strategy chain proposed protocol attain to the following. The shared key is created by the master A between device E and M. In the next slide, I have secured unclonable command pass protocol using SUC. And
I request you please conclude the presentation.
Okay. The attachment is a target of this protocol, and it's a mechanism to validate and verify the integrity of the system, and it's the proof to fulfill the security requirements, which we had also in the beginning. As you said, due time, I will not go into the steps, but you can read the steps later in the paper. And at least this work proposed new mechanism for securing medical entities and their operating processes. The attained security level may counteract all expected replacement and spoofing attack in the modern smart open medical environment, and the realization complexity is relatively low, and the attained performance and security are scalable and may fulfill the most expected modern medical security requirements. For future work, we will focus on authentication and authorization of system personnel, system users, with combining biometric with hardware identity. Thank you very much for listening.
Thank you for your presentation.
Thank you very much for your good presentation and good presentation for the design for the good presentation. I have the question to you.
Yes.
Can you explain me what are the application of FPGA over the CPLD?
The application of FPGA?
Yeah.
We use FPGA here to create our clone resistance identity. The FPGA is here just used, but we can use also existing FPGAs. That means if any device has already FPGA inside, then we can create on this FPGA our clone resistance identity.
Can you name the FPGA?
Yes, it's from Smart Fusion as example. In the paper, you will find also more than one proposal. for SUC and which hardware we use, but the Smart Fusion 2 was our proposal.
Now it is okay for the FPGA. FPGA, it is a volatile device and it can be operated minimum about from 1 volt to the 3 volts. Okay. But the point is that, as you mentioned your presentation, you are also be more concentrated about the SRAM puff. So what is that SRAM puff? Do you know the working about the SRAM?
We don't recommend to use SRAM or puff. Our proposal is to use the puff. The puff have an inconsistency issue. And we meet a lot of people, especially mathematician, who works on inconsistency of PUF. And a lot of projects by big company like PMV and so on use already PUF and have a lot of problem with the inconsistency of PUF. The idea behind SUC is to go far from such analog PUF and have a digital PUF. You can call SUC also the secret unknown cipher as a digital PUF, you know, and you will don't have any inconsistency here, because you can see here based on the SUC function the output is always stable, and you will have also more than one secure pair which you can use also in your application. In the PUF, the secure pairs are also limited. In case of SRAM PUF, it's always the same. You have just one pair which you can use in your application. And after a lot of work with fuzzy extractor to get the response stable in each request.
Now it is okay. Thank you very much. Now it is open to the room. If anyone has a question, you can ask, please.
You can drop your questions in the chat box, open chat box forum, everyone. So we'll move on further. I also kindly request
thank you very much.
Presenters to stick to the time schedule, that is 12 minutes plus 3 minutes for question and answers, by not letting this session overrun. I kindly request all the presenters to keep in mind in this. So we'll move on to the next presentation, that is Christos. Yes, you can share your slide, ma'am. Are you able to hear me?
Yes. Can you hear me?
Sorry, pardon me for that. Yes.
Yes, please. It is visible. It is visible. Okay.
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 Hello, good. Can I begin?
Yes.
Yeah, please start.
Okay. Hello. Good evening to all of you. My name is Christos Mourzios from Apifon SA. The title of this presentation is an experimental study of a multi-protocol IoT gateway. The presentation outline begins with the smart water and the project purpose, the smart water approach, the end devices and the custom multi-protocol gateways used, the project architecture, and finally the results and the conclusions. Smart water is a pilot research project taking place in Thessaloniki in Greece. Its first purpose is to design a novel integrated infrastructure for the intelligent management of the water network that utilizes telemetry and remote control technologies. Secondly, research and develop alternative technologies for the implementation of real-time telemetry and remote control in the Thessaloniki area. Research and develop pilot tests for water consumption and data analysis system. And finally, evaluate the overall system based on operational efficiency and financial return on investment. The question is how water utility companies leverage metering technologies. Real-time water consumption offers improved customer service, revenue protection, tackle water theft, customer intelligence, and many more, while the ability to remotely control water supply can reduce costs and protect water resources. So far, water utility companies make use of methods like AMR or AMI, which actually a one-way communication from the meter, from the water meter to the meter reading device, where the data is collected at regular predetermined intervals like day, week, or month via walk-by or drive-by methods. Of course, these techniques cannot offer real-time telemetry or remote control. Our approach, the smart water approach, proposes firstly a hybrid fixed network comprising of gateways installed in predetermined installation points inside the consumer premises and wireless smart end devices like water meters and water valves that offer dense wireless communication of about 1 uplink per 50 seconds, high accuracy, and smart features like leak detection, tamper alert, and many more. This is a generic view of the smart water's architecture. The first layer is the sensors layer where we have the water meters and the water valves. The second layer consists of the telecommunication equipment, namely the gateways. The third layer has to do with decoding and decryption and all the servers. The fourth layer has to do with data processing and analytics. And in the last layer, we have two user applications, one for the consumers and one for the water utility company administrators. The end devices we use at the moment are water meters, wireless water meters from 5 different manufacturers, transmitting either or WMBus protocol or LoRaWAN protocol, while the valves come from one manufacturer and all work in LoRaWAN protocol. The biggest challenge faced throughout the project was the fact that there isn't any commercially available gateway that can communicate simultaneously both with WMBus and LoRaWAN end devices, and at the same time remain connected bidirectionally to the central server. That's why we designed and manufactured custom multi-protocol gateways consisting of these components, of these electronic modules, of these 6 modules. The gateway has low profile. It offers bidirectional communication, which is very basic, which is very fundamental if we want remote control. It is actually a relay between the end device and the server, and it can be applied to any MBUS or LoRa end devices. The second challenge we faced was the exact location of these gateways in terms of minimizing packet loss and cost constraints. That's why we designed one field tester device consisting of these electronic parts, which actually emulates the way the gateway operates, and it defined the optimal gateway location inside the consumer premises, for example, in the entrance of the building or in the water meter's chamber. It's flexible and versatile, it has low profile, and it's autonomous since it can work with any commercially available power bank of 2.1 amperes. The field tester device is handled by a custom user interface application run in any cell phone. On the left, we can see the initialization page where the user can shut down, reboot, or control the device, while on the right, we see the results page and the exact location and address of where the test took place. These are indicative pictures of installed gateways and the devices, both water meters and water valves. In order to assess the multi-protocol gateways reliability in terms of delivery of packet loss, we extracted 6 different connectivity scenarios for all end devices, both WMBus and LoRaWAN. From the results, it is clear that LoRaWAN protocol clearly outperforms WMBus in terms of penetration and packet loss, since LoRa can even reach 100% of packet delivery, while the WMBus case showed a packet loss of more than 50%, as we can see in scenario number 5. The conclusions of the pilot project and the pilot test so far are that for a reliable and uninterrupted bidirectional data transmission, we need a hybrid fixed network using modern and RF and conventional RF protocols. LoRaWAN significantly outperforms MBUS in terms of coverage and packet loss. Implementing such a network requires the use of multi-protocol gateways, and MPG is a reliable and promising solution for deploying fixed wireless network for large-scale IoT infrastructures. The research is being co-financed by the European Union and the Greek National Funds. This is the end of the presentation. Thank you for your time, and I'm waiting for your questions.
Now this is very good presentation for your deliver from here. I have the one query related to as you mentioned from here, multiple gateway protocol. So this multiple gateway protocol, it is totally depends upon specific protocol, or you design from this protocol for the specific design.
Yes, because we chose these specific manufacturers, which are the best in the industry. We were forced to design this because even if MBUS is a much older protocol, we had to use MBUS water meters because there aren't any MID certified water meters working on LoRaWAN or better or newer protocols. And so given that the water valve works on LoRaWAN, we had to design this specific multi-protocol gateway which can interface with LoRaWAN and MBUS and connect to the server with GSM or narrowband IoT protocol.
Now, another question to you. Can you elaborate me whatever the embedded board you are display that particular protocol? Is it that board is developed by yourself, or you are purchasing from some vendor?
Can you repeat again, please?
Well, that embedded board you display in the presentation.
Yes, this one.
Yeah, that IoT board.
Yes, this one.
This one. So this board is designed by yourself, or you purchase through the vendor?
No, we gave it. We designed it in conjunction with a PCB company, which designed and manufactured the PCB, and on top of it, we place the modules. As you can see, these 6 modules.
Yeah, that I understand. I'm keenly interested about how to design such type of boards, and you are doing a very good job. So thank you very much from my end. If you have any question in the room, they can be asked. You please ask the question. Okay.
Thank you for your presentation, Christos. And so do we have the presenter of the paper Smart Cities for Sustainability and Analytical Perspective? I'm not able to find you. If yes, then you can just message me.
I think so. No presenter is available, so we can go ahead with the next. So
we'll move on to the next presentation, that is a presentation on security requirements elicitation, a smart health case. I have unmuted you, Anas. Yeah.
Thank you very much for
start sharing your screen.
Okay. All right. Can you see my screen?
Yes, it's visible, so you can begin.
Okay. So first of all, good morning or good evening. Thank you for introducing me and giving me this opportunity to talk about my work. I will be conducting a presentation on our paper, Security Requirements Elicitation, a Smart Health Case. So the presentation is structured as follows. Firstly, we will discuss smart cities and their security challenges. Next, security engineering implementation as a requirement for security by design. After that, I will present the solution we suggest applied to a smart health information system, and we will finish with the conclusions and prospects. So smart cities enable the possibility for optimizing our way of life and using massively gathered data and technological development to provide services such as self-driving cars or smart health, laying to the groundwork for a citywide interconnected grid of people, services, and data. The issue that arises is the necessity for protecting citizens, vital organisms and services against attacks. Seeing how common and easy to perform cyber attacks are, leading smart cities such as Singapore or Hong Kong emphasize the necessity of laying down proper secure infrastructure for security, from solid architecture to adequate legislation for them to thrive. This diversity is also reflected in the number of standards existing for each smart city aspect. So we acknowledge the difficulty of security management in such circumstances and have designed an approach to support it all along the engineering lifecycle. So our goal is to design an approach assisting in information systems security management. In order to get a grasp on how to secure such complex and fragile and critical systems, we fall back onto the security engineering process, as well as recognized security standards. So these security standards, as they are presented, security standards, for example, ISO 21827, presents the security engineering process with these three main areas. So first of all, the engineering process defines, um, excuse me, I'm having difficulties. In the engineering process is where we deal with the different components of the system. Out of this area, we established two models represented by the packages, where we answer questions like what are the components of the system? How do they interact? Who is responsible for each component? And what are the characteristics of each component? The process model serves to detail processes. For example, what do these processes aim to achieve and what are their deliverables? The second aspect is the risk process, where we handle the risk analysis concepts for each asset, where we answer questions like what are each asset's vulnerabilities, what can abuse them, how common are these attacks, and so on. So the goal here is to have proper repeatable risk analysis where ensuing risks are accounted for. Lastly, the assurance process is where we determine what are the security requirements established for the system are and what are their sources and how are we going to be able to satisfy these requirements. So we have to, first of all, make sure we don't have any conflicts between requirements. For example, if we have requirements coming from different sources, or either establish that some requirements are just literally exactly the same, since in some legislation, we have some laws that are established based on some requirements from some standards and so on. So for these four models, we have created many diagrams, first of all, encompassing the concepts within these models. And then we have used these concepts to extend through a profile the existing SysML diagrams. So first of all, let me show you the architecture. So these models interact and complete one another, giving insight on the overall state of security within the system. The processes are but assets that we detail for the importance they're given in standards. A process, for example, must be well executed. For example, we have set of quality requirements so that we make sure that the process is actually useful. We have risk analysis that must be done for every asset. It shows us whether an asset is critical or not, depending on how many vulnerabilities it has or how many interactions it has with other assets and which critical processes it interacts in. So risk analysis is done on each asset in the system, and we use security controls to satisfy security requirements as well as for risk reduction. But these controls themselves are only assets that we created for the purpose of risk reduction or requirement satisfaction. So they also must go through risk analysis to secure them as well. So we have a set of diagrams that complete each other that we will be applying to our case on smart health information systems. So to apply our approach, the Deming wheel, the Plan, Do, Check, Act wheel, is at the heart of it all, since applying all of this at once won't be effective, and all organizations must constantly keep changes and adaptations to keep up with the evolution in the field of security. So the models we've created are extended CSML diagrams, as I will show you next. So first of all, in the plan phase, we must determine all the assets in the perimeter. We have, for example, actors such as this patient that has a blood pressure sensor connected to him. And this blood pressure sensor is collecting information about this patient, that is physiological information. So as you can see, we have different blocks with different stereotypes, and actors are different from intangible assets or physical assets, but they're all assets to the system. We try to treat them differently because they interact with one another differently. For example, an actor must have skills. Intangible assets cannot really be fixed, but physical assets can. Next, we try to have a security analysis done by the responsible for each asset, because they're the one who know that asset. They know their assets pretty well. So for example, a blood pressure sensor has a vulnerability such as plain text data storage, and we represent that by a block stereotyped vulnerability. And this vulnerability can be taken advantage of through the threat of data eavesdropping. Someone could be eavesdropping on the data that is contained within this sensor or transmitted by this sensor, and use that in order to take the information for himself or for other purposes. But then we have a risk that is a data confidentiality breach. So we must do these risk analyses for every for every asset that we have within the system in order to determine all the risks and moving forward in order to reduce all the risks. But before we do that, we must address the security requirements. And here, as you can see in this requirements diagram that has been extended to include, for example, domain requirements as a specialization of requirements, of security requirements. Domain requirements are linked to standards, which means that the different requirements by the standards are detailed in domain requirements that also can be decomposed using the containment relationship. We have also some other requirements from contracts. For example, an equipment supplier has many requirements with the hospital. Like, for example, if you want to buy equipment, that equipment must have audit trail, electronic access control, and configuration software. For example, we also have some GDPR laws for personal data and for personal data protection coming from a governmental entity that is here the EU Information Commissioner. And so we're going to have many security requirements coming from different sources that we must treat. And the difficulty here is that we don't know which requirements are satisfied and which are not, and how many security controls we're going to need in order to satisfy all of these. So the goal here is to have these requirements decomposed until we have the root security requirements that we can implement security controls for. But we must first determine whether we have conflict relationships between these security requirements in order to see whether it is actually feasible to do this or to satisfy these requirements, and to possibly find copies. For example, as I said earlier, some requirements are just copies of others, and we don't require...
Presenter, you just have 2 minutes left.
Okay, thank you. And we probably don't have to implement many security controls in order to satisfy all of them. We might even use one. And therefore, we urge high-level security responsible to take the time to find duplicates and probable conflicts. The addition here, the most important addition here, is that these are SysML extensions. So we can have OCL requirements for the completeness of these diagrams, making sure that every security requirement is satisfied. We can have test cases verifying every security requirement. These test cases might be operations or activities or whatever. As you can see in the do phase, we have security controls implemented. For example, pseudonymization and encryption of personal data reduces the risk for data confidentiality breach, but it also satisfies the requirements set out, for example, by the GDPR, the EU law. Next, in the check phase, we have, as I said, those test cases that we can implement. We also have those OCL requirements that we can have, telling us that maybe some risk isn't reduced, or maybe a requirement doesn't have a security control that satisfies it. And then we can act upon these results from the check phase in order to either replace assets within the system or add new ones or reconfigure them. And therefore, we would have a continuous improvement of the security state within the system. So to conclude, we have created security diagrams usable by different profiles, ensuring security by design. We elaborated steps to ensure the completeness and to encompass all the variables affecting security. We have applied this to HIS case, showcasing its usefulness with multi-source security requirement elicitation. And we intend to hone this process as well as provide an implementation tool for it in order to have an interface to help implementation. That will be all. Thank you for your attention.
Thank you very much for your good presentation. I have one query about that for your presentation. You given the you are using the word about from so many where as a RIX processor techniques you are using.
I'm sorry, I didn't understand your question.
Can you elaborate me what are the features of RIX processor?
Of the what?
RIX processor. RIX processor.
So in here for the risk assessment, we have a diagram that just showcases the different vulnerabilities of every asset. So we can have a list of all the vulnerabilities for each asset, telling us which asset is actually the weak link in the security of our system. And we can have, we can look for the different threats that can take advantage of those vulnerabilities, and that creates the risks we have. And so we can have a whole diagram telling us about the different risks that we have, the impacts they might have on our system, and the level of risk, this asset is on, right? And so, sorry?
No, please continue.
And so we can define whether an asset is actually critical or whether it's the weakest link or a lot of other things mainly. And then we can determine how many resources we're supposed to be spending on that specific asset, whether it's actually worth spending that many resources on an asset that's really, really vulnerable. Maybe replacing it might be a better idea. So the diagram actually showcases a lot of these things.
So thank you very much for your good answer. Now it is open to the room. If anyone asks, please.
Yes, thank you. Thank you for the presentation. So our next presenter is Monica, I have unmuted you. Can you hear me?
Yeah, I can hear you.
Yes. Please begin with your presentation.
Yeah.
Kindly stick to the deadline as well. Yeah, 12 minutes for presentation and 3 minutes for question and answers.
Yeah, sure. Thank you. So I hope you can see my screen.
Yes, yes, yes.
Yeah. So I'm Monica
Okay.
Mundra from Copenhagen Business School, and my topic of presentation is Smart Cities for Sustainability and Analytical Perspective.
Okay, I'm sorry to interrupt you. Can you maximize this presentation, please?
Yeah. Is it okay now? Yeah.
Thank you. Thank you.
Yeah, thank you. So I'm here to present about smart cities for sustainability and analytical perspective. So for this presentation, I'm going to cover the outline as introduction, research method, data analytical methods, discussion, and finally the conclusion. So smart cities, when we speak about the definition, it is an initiative for resilient, sustainable cities with the help of AI and IoT. So there are 6 different factors which revolves around the smart cities, like environment, infrastructure, people, transport, health, education, government, and technology. So smart city, which is built around all these sectors, is known as a sustainable development smart city. So for this research, we have begin the main research problem to identify the research aspect covering smart cities and sustainable development, and also to identify the type of analytics that are followed in the smart cities research. So for this, initially we have used the keyword smart cities and sustainable development. So out of them, we have considered the top journals which were around like 425 papers which were speaking about smart cities and sustainable development from ACM and IEEE transactions. Then we have applied the second level of filter, that is title and keywords. So we have only identified the respective title related to smart cities and sustainable development. Then in the third filter, we have digged more into detail for abstract and summary, which gives us around 123 papers. Then in next level of filter, we have studied more in detail about framework, tools, and technique of each of the paper. So while coming to the next filter, we have identified the sustainable development goals where we have considered each factor which is talking more about sustainable development goals in any of the areas that we have seen in the previous section. So we have lastly 54 papers which we digged in detail for this research. When we speak about data analytical methods, there are 4 types of methods as we know. That is descriptive, diagnostic, predictive, and prescriptive. Descriptive, it speaks about what is happening in the organization and identifying the fundamental trends and reasons why it is occurring. Diagnostic, it explains why it has happened. Predictive, it forecasts what can happen. And prescriptive, which prepares an support system based on the information that we have collected. There is a minor difference between diagnostic and descriptive while studying in this field of research. So we have merged this into a single category, that is descriptive analytics. So while going ahead for discussion and conclusion of this analytical research, we have categorized our whole research into descriptive, predictive, and prescriptive. So when we can see that the trend has been increasing from year 2010 to 2019 till date. We can see that most of the analytics are aligned with the prescriptive, which shows around 39% of the entire contribution, 33% goes for the predictive, and 27% goes for the descriptive analytics. So which means that there are much of the research nowadays is more aligned to the prescriptive, which helps us to identify what likely measures can be taken to build an efficient support system. So when we speak about descriptive analytics, in this we have considered the research papers and case studies. So in my, there are 3 different tables in my paper. So in descriptive analytics part, the paper number 17, 26 and 27 are the research papers and the reports or a survey which I have, I have gathered around to see how exactly it is. The methods like ubiquitous computing and statistical methods and cloud computing are mostly discussed over here. Digital transformation focused in governance, environment, and cybersecurity are even considered in this section. So predictive analytics, in this type of analytics, it is a data mining method which is mostly applied in traffic flow in transportation to identify the more optimal routes and also to ensure how the pollution can be controlled using this type of analytics. There are also some methods which adapt the cloud storage and simulation in different healthcare sectors. One best example to quote here is an doctor prescribed knee surgery, which gives the live implementation of a knee to the doctor, and the doctor advises the patient accordingly the needed care that has to be taken here. There are also an integration with Arduino for innovative approach in waste management in this analytics. So this analytics, it speaks about like how we can forecast and how we can control the different methods with the statistical and the data mining methods. In prescriptive analytics, there are many research which were focused for the transportation again, and also to build the route planning application with less emission of reduction. There are also some research which focuses on public values and smart cities, or like how the governance and the smart cities can be correlated with each other in designing of smart cities. Smart homes with IoT technologies and like tracking the energy usage for the behavioral changes are also being adapted as a prescriptive analysis. So there were many papers where it was discussing about like how to build an efficient support system or IoT with the help of the energy changes that we have. So while coming to conclusion, there are a high number of research articles in prescriptive analytics. Like when we see about the trends, there were like many, the research now is focusing on the prescriptive analytics. The green line shows like actually the research after examining the current trends, what likely can be forecasted and how based on the information we have, we can build an efficient support system is mainly focused nowadays in a smart cities research area. So it is good that most of the research is focused on a prescriptive analysis by exactly understanding where we have to forecast our smart cities. Then next is the future analytics and adaptive measures are also considered in research nowadays. And sustainability development is the primary focus of the entire research. So these are some of the references that I have used, and thank you.
So thank you very much, ma'am Monica. You are given a very good presentation related to research on the smart cities.
Thank you.
Can you explain me what exactly at your end the meaning of smart cities?
So what I mean?
Yeah.
Okay. So yeah, basically smart cities is, as I said, to see the transformation in the every sector. It's not only like
it is okay. It maybe depends upon the cloud, or it may be for the AI.
Right.
Yeah, as you are doing a lot of research, how many research publication, how many journals are available? So what is your opinion about smart cities?
Yes, as I said, like now I can see after going through all these research papers and in this smart city while doing this study, I found that yes, there are many things which are like going in the direction of forecasting. Like, okay, what we can exactly build up, how we can build an efficient support system or with the using with the cloud or simulation or any type of technique. So yes, I felt that there are many papers which speaks around like descriptive analytics, like a review or a report or a survey paper. But still, there are many papers even considering that they are like going in a direction of forecasting what things can happen and how we can do it.
Okay, thank you very much.
Yeah, thank you.
Thank you. Thank you for your presentation, Monica. So we'll move further. Our next presenter is Mehdi. I have unmuted you. Are you able to hear me?
Hello, hello everybody.
Yes, yes. You can begin with the presentation. Hello.
Yeah, hello. Yeah, I will share it right now.
Yeah. Are you able to share screen? Mehdi?
Yeah. I'm with you. I'm with you.
Not able to view your presentation. Please start sharing your screen.
They demand me the permission to.
Yeah, I have granted you the permission. You need to share your screen. Select the share screen option and select the file which you want to share. Yes, it's visible now. Just maximize your screen.
It's okay.
Yeah, yes.
Yeah.
So hello and thank you for being here. So I'm Media Guzel, studying in the Laboratory of Engineering, Industrial Management and Innovation in Faculty of Science in Stade, Morocco. So my presentation will cover a new method for hyperspectral reduction based on the trend of the electromagnetic range. So my answer first, let's start with the small introduction and to extract our problem, and there will approach for explaining what the proposed method and hello.
Yes, you are audible,
And
Mehdi. Go ahead with the presentation.
You please continue your presentation.
Yeah, and afterward we got discussed the obtaining the results, profits, and to conclude, we will have a small summary. First of all, what means hyperspectral image? So it's like other spectral imaging, collecting and process information from electromagnetic spectrum. So this image contain human visible, and also they have some visibles we cannot see. So the spectral imaging divides the spectrum into many more bands, and this technique for dividing images into bands can be extended with. So the engineers build hyperspectral sensors for application in astronomy, in agriculture or physics, and also in surveillance. And there is certain objects leave unique fingerprints, and with these fingerprints, we can allow scan objects. So in my example, we take a photo the Pavia University. So it's a photo acquired by the ROSES sensor during a flight campaign over Pavia. Pavia, it's a city in northern Italy. So this photo, this hyperspectral image has some properties like 610 pixels, and also has geometric resolution 1.3 meters, and also has 9 classes for each in ground truth and the real image. And it can also it can describe samples in the figure as a broad black strips. So this photo is the real. It's the Greater Pavia University at the top, and in B we have ground truth, the ground truth image, who has some classes. We can identify the or scan objects in this image. So the electromagnetic we have a visible, as we know, in 400 until 800 we can see in human eye, and also there is some used infra, it's a sphere, ERA and ERB, and also the visible and a little of UV. So the problematics. First, we have data storage, transmission, and technology processing of hyperspectral imagery, and also we have duplication of existent information between adjacent spectral bands. So we have some bands noisy, or some bands are redundant, and we have huge phenomenon. So the huge phenomenon, normally we fix the number of training samples, and the predictive power of classifier or regressor increase of dimension of feature used is increased, but then decreased because there is some bands noisy or some bands redundant. So the dimensionality approach, we select two dimensionalities. So there is feature extraction. We extract first, and after that we select. There is several methods have been proposed in the previous years to treat this problematic without losing the useful information. Okay. And among them, the dimension reduction technique, which is divided into two main categories: feature selection and feature extraction. So the proposed method, as I told you in the previous slide, with this algorithm, we have extraction stage, selection stage, and classification stage. So in extract stage, we extract the trending, the electromagnetism trend of each class, because it means 9 objects, and we extract also the trend magnetism of each band, and we do correlation between them. And after that, we have a matrix of correlations, and we extract superior half. It means high correlated. And after that, we calculate the K of means, the K of means to divide and separate this combination into clusters. In each cluster, we do a selection stage. We calculate correlation between chosen class and each band, and we do sort, and we take top of score, and we have the selected bands. After that, we have classification stage, which is with SVM or KNN to see the score, or to see how is similar to the real image. We have we do two methods. We do mutual information and also correlation. In blue it's mutual, and in red is correlation. You can see the correlation, it's more efficient than the mutual information. That is in SVM, and we do the same thing in KNN. Also, I think it's the same correlation. It's more and better than mutual in formation. So in conclusion, firstly, it's this new method in hyperspectra, it's enabled to optimize feature subsets, to reduce computation costs while improving the classification accuracy. So the number of bands used for classification was reduced from 103 bands to 48 bands. So while the classification accuracy is increased from 90% to 94%. I think these results confirm that this new method is rigorous tool for selection band. So I let you some references. You can read it. And thank you for your attention.
Yes, thank you very much for your good presentation. Can you give me the one answer about that related to your presentation? Can you define me what exactly the meaning of accuracy?
The meaning of accuracy, it's about the selected bands because we reduce. Firstly, we reduce, and we should have the bands normally should be very, very accurate to the real image.
Okay, thank you. Thank you very much. Now it is open to the room. If anyone has a question, he or she can ask.
Thank you, Mehdi, for your presentation. So we'll move forward. Our next presenter is Manju Arora. I have unmuted you. Are you able to hear me? Manju, please unmute yourself. Yes, are you able to hear me now? Manju, are you there?
Manju Arora, you there? Actually, we are not audible. Manju Arora, you can just check your mic. Manju, are you there?
I think volume is not audible. Please.
Might be. You can just increase your volume. Otherwise, check your mic.
Or else we can move on to the next and we can take
Manju, you can do one thing. You can just leave this meeting and again rejoin the same. I am just stop sharing you. And secretary, we can go ahead with the next presentation of Viraj. Manju, I request you, you can leave the room and again join it. So we will consider your presentation.
So our next presenter is Viraj. I have unmuted you. Yeah, are you able to hear me?
Yes, I can.
Yes, you can start sharing a screen.
Yeah. I have shared my screen. Can you?
Visible. Yeah, please begin.
It is okay. It is okay, Viraj.
Great. All
okay.
Right. Hello all. I will try to make this really interesting so that all of you have some earnings from it. So, AI has shown great successes, right? From finding objects to generating text. One significant observation though has been that AI requires a lot of data. Right? The more data you have, the better the AI performance usually is. So I'm from the industry and I had a large AI team, right? And often you would hear the members of the team complaining that we don't have enough data. Right? So data is always a bottleneck. So the problem is not that data is not available. Data is available. The problem is that many important data sets, they are very scattered. Right? So we call them data islands. So for an example, right, if you consider different hospitals, you'd find that every hospital will have its own data set, but then it's really scattered, right? And for conventional machine learning algorithms, um, all the data has to be first collected in a central storage, and only then the algorithm can be trained on it. Now, of course, centralizing data comes with a lot of challenges in a way. Right? So, challenge number one is that often data exists in different formats. And if we want to centralize it first needs to be marshaled into one common format. Uh, Also, this process of centralizing everything need not be an operation which you do only once, since the sources may also be uh, continuously gathering the data. This has to happen in a on a rolling basis. Of course, there are other challenges which the privacy regulations pose, and companies or organizations may not be very comfortable sharing the information they have. So one solution to this is called federated learning, right? And so to really summarize it, right, what federated learning does is that instead of getting the code to the data, what we do is that the data is stored where it is, right? So if the data is stored in your private servers, the data will remain there. It will not be moved outside. And without moving the data, federated learning will still allow you to train your algorithms on all the available scattered data sets that you have. So what happens in federated learning is that there is one central server, which you can see in this small cloud here, and at each client or each data source, you would have a separate application installed there. And each client essentially trains the model on the private data that they have, and they send only the updates back to the server. What the server will do then is that it will aggregate all these updates, and the server will then send the the aggregated model back to the individual clients, and this forms one round. The great advantage of this is, as you can see, right, that the data is always stored in the privately controlled client application itself, and it will not leave the client at all. Of course, what happens in federated learning is that we produce only one common model, right? So we have only one common model that has been trained on data from all the clients, and in practice this will often fail, right? Because every client, the data sets that a client will have, uh, the will be what we call as non-IID, right? And due to that, this one common model will not actually work on each, or work for each individual client. What happens because of this constraint is that uh, so for clients that do not have much data on their own, that is actually good, right? But for clients that have enough data to train their own models, they do not have any incentive to participate in this. So this brings me to the topic of researcher, which is that there have been techniques used to take this one common global model and then further personalize it to each individual client. And personalized models are then expected to work better than the either the model that the client can locally train on his or her own data set, and also the one common shared global model. So before I get into the different personalization techniques itself, I would just give you a quick overview of what a neural network consists of. So neural network is made up of individual nodes. So all of these circles, each circle is a node, and these nodes are stacked up in the form of layers, right? So this is the layer which takes the input, and these are the layers which do some work on the input, and then the one layer at the end is called the output layer. So I will just quickly touch upon the different techniques that have been used to uh, personalize shared models for individual clients. The easiest technique available is that we add the client's context into the feature set itself. So the context of the client would then become a part of the input itself. This can work well, but of course it comes with the drawback that since we are incorporating the context, this adversely affects privacy in a way that even if the data is not really moved, you would still end up revealing private information of the client to the central server. So that is technique one. Technique two is what we call as transfer learning, in the sense that so I'll just explain this with an example. So if I have a neural network here which has been trained to identify cats, so my data set A consists of images of cats, and the model that comes out here, model A, has now learned to identify cats. Now instead of cats, I want this model to identify dogs, and I have a small set of images of dogs also. So instead of training this entire network independently on dogs, what we would do is that we would take the base layers of the model that has learned to identify cats, and then use dataset B only to train the uh, last few layers of it. So with that, our model B has now learned on images of both cats as well as dogs. So with transfer learning, what we can do is that we can take the global model, and then and then each individual client can further train it using their local data sets. That is approach number two. We come to approach three, which is called as multitask learning.
Dear
So
presenter, you just have 2 minutes left. So you
okay,
can
so
conclude.
I'll just rush through it. So in multitask learning, we we essentially allow models to solve multiple tasks at once. So we can model this as, so every client can be considered as a separate task, and through that we can achieve model personalization. In meta learning, what happens is that often the model which has been trained for global accuracy, it may not be subsequently personalized well. So model agnostic meta learning is an approach that will allow us to find a global model that is highly adaptable to personalization. Knowledge distillation is an approach which which avoids the problem of overfitting when we when we personalize the model for individual clients. And the last approach is where we split the model into two. The layers at the base, they are trained first using data which is aggregated from all clients, and then the layers at the top, which are called personalization layers, are then trained on that individual client's data itself. So I will just summarize this in a way, right? That most work on FL has so far focused on measuring the performance of the final global model. However, global performance is not really important, right? Because if we are going to personalize them afterwards, the global performance is not relevant at all. As part of I just explained to you the different approaches, but as part of the next steps in this theme, we would like to evaluate each approach. So we would like to implement each approach, evaluate them, and then compare the approaches that we just saw. That brings me to the end of my presentation. Thank you for your time and attention.
So very good presentation, Kulkarni ji.
Thank you,
So
sir.
can you explain me where this data is to be applicable for the research as well as for the production oriented?
Right, sir. Right. So I yeah. So we actually work on building AI models for healthcare, right? So we often work with a lot of hospitals, and the problem which I described here, that is very applicable because the hospitals are not very willing to share the data that they have, right? So we plan to productize this where we can tell them, or we can tell hospitals that the data that you have will remain with you, so it's safe, right? We will not compromise its privacy at all, but we would still allow different clients to build models where where the final model will help everyone, right? So yeah, I mean, with different regulations, I think the only way to move forward in using AI in healthcare is with this sort of privacy reserving approaches.
So many thanks, Kulkarni ji. Thank you very much.
Thank you, sir.
Thank you. Thank you, Viraj Kulkarni. Next presenter is Manju Arora. You need to unmute yourself. Are you able to hear me?
Yes.
Yeah, please share your slide. Yes, ma'am, your presentation is visible. You can begin with the presentation.
Hello, good evening, ma'am and sir. Myself, Manju Arora from India. Hello, sir, am I
Please
audible?
continue.
Okay.
Yeah,
The title of
yes, you are audible.
Okay, so the title of my presentation is Task Scheduling in Cloud Infrastructure Using Optimization Technique Genetic Algorithm. The basic outlines for the presentations are introduction, objectives, proposed model, improved ACO algorithm, result analysis, and the conclusion. Here, everyone knows what is a cloud computing. It is an ocean of resources, some applications, and the services that are available to the client through internet on the basis of pay-per-use, as per they want to use. This cloud computing accessing mechanism helps to access the resources, application, data, memory, power, service, with as per their user requirement in a cost-effective manner. The main objective of my research is job scheduling in cloud infrastructure. The main aim is for considering the parameters like instruction count and the grain size of the task. The proposed task scheduling model in cloud environments is like this. And there are different components like user, receiver, and the processing task classifier, the data center manager, and so and so. Each and every scenario has their own set of accountability. The suggested model has following task scheduling in cloud environment. Is the first section is for the user. When they send a request and looking for various types of resource services. The second section is categorized into the two subsections. First is the pre-processing and other one is for task classifier. The pre-processing section is responsible for computing the attribute of different jobs and maintaining the quality of service. It encodes with various attributes into a user job attribute vector, which is showing in this slide. There are various parameters in this UJAV, like types of service, expected instruction count is for EIC to determine by the preprocessor, arrival time to indicate the arrival of job, the deadline is for completing the job with no fine, WC for waiting the time, that is the maximum time is required for any processing unit to complete their job. The delay cost is for penalty, X/S is for expected time or the exclusive or shared access time. What type of unit a user wants to access the processing unit. Next one is for expected time for job performing. Expected cost, what cost we require for the completion of job. The last attribute is time versus cost, that is the variance. That indicates how the cost increases by decreasing in time. Next, the improved scheduling algorithm. The improved task scheduling algorithm can be used to rectify the problem and find the solution. This improved algorithm is basically, actually, the genetic algorithm is an iterative process. There are multiple helper algorithms, which I'm not going to present in my slides. Generally, the various stages. First is the initialization phase. Initialization phase is just for finding the population generated randomly. Next is for selection procedure. For this selection procedure is help for finding the on the basis of their fitness function, finding the most appropriate chromosomes from the selected population. After the selection of population, the next operator is a reproduction operator. The reproduction operator is to generate the offerings. After generating the offering, the changeover, the replacement is being done on the basis of the fitness value. Fitness value can be calculated with the help of equation time search plus the load. Time search represents that the survival rate of virtual machine with their small spikes, and the load is the nature of load. If the value of the chromosomes on the basis of their fitness value is greater than their previous one, the old population, then it would be replaced, otherwise it discards the new population. And the last stage is the concluded condition by applying the various rules of termination condition to display the result. Task scheduling algorithm will execute in the various data centers, and their experimental results shows that this IGA algorithm, this is improved genetic algorithm, finish time is lesser as compared to the traditional genetic algorithm. The conclusion of my research is for finding the minimum finish time on the basis of various attributes like finish time, instruction count, and the cost. And the future scope is if we are using the hybrid approach, like ACU and genetic algorithm both are implemented with each other, that could be the next scope area. Moreover, I consider it as a fixed binary stream. If in futurely I actually recommend for the dynamic binary stream for calculating this by applying this genetic algorithm. Thank you so much.
Thank you very much, ma'am. Presentation. Yes, ma'am. Manju, can you give me the answer about that? What will be the evolution of genetic algorithm?
Evolution, not getting, sir.
Evolution means generation of genetic algorithm.
There are some various steps in genetic algorithm. Firstly, for encoding, for decoding and finding the fitness value, and for finding the this initialization phase, randomly generate some population among all the respective numbers on the fixed string.
It's okay. Okay, thank you very much. I think this is the last presentation, Aman sir.
Yes, sir.
Yes, sir.
Yes. Now, can I give my concluding remarks?
Yes, sir. Of course.
So, thank you very much, all the participants across the globe. Now, in this module, near 7 papers are published across the globe, and they are very good presentations. Someone is belong to from smart city, someone is belong to from there is a computer science. They are like a scheduling as well as from the cloud computing. I'm very happy to see the research is to be going on across the globe, especially a very high levels. So I once again thanks all the participants across the globe. I also thanks to the organizer. They are given a good platform to the researcher, and they can develop to publish their works in a good like this international conference. So I once again thank you very much to all of you.
Thank you, sir. Thank you for your remarks. And I would also like to share your
Thank you, sir.
Thank
you once again. It is a sir small token of thanks to you.
Okay.
That it is quite difficult to chair the session physically.
Yes,
okay. Thank you once again to
okay.
give your memorable time. Apart from that, for all the participants, thank you for the presenting the paper. We have already forwarded and started all the IEEE publication process. So might be all the authors will receive the copyright form. Those who has not received within end of this week, you will definitely receive the same. Apart from that, we have already released all the necessary data.
Yes, thank you.
The presentation certificate, participation certificate, the payment receipt, the end of this session. So you will receive the same. Hope if you have any particular query, you can write to the support team. We are happy to help you. Thanks a lot. The next only, not the least, but if possible, you can just open your camera so we can just click the memory. If we are not able to meet at physical level, so we can just take it digitally. So for next 20 seconds, you can open your camera if you are comfortable. Yes, thank you once again. Thanks a lot to all the participants. If you have any particular query, you can write to the support team. Thank you. Stay safe, stay healthy. Thanks a lot. Secretary, you can just close the session.
Thank you. Thank you, everyone.
Thank you.